Okay, okay, guys. So we have 26 people on the line, so I think we can start. So hello all. Thanks all for coming virtually, of course, to our meetup regarding application security hacking, security validation. We actually prepared a very unique topic to talk about. I'm also excited from the lectures. I think each and every one is a professional in his field. I also do want to thank also Pentera for sponsoring this event, keeping it going. And also we prepared a very special, unique sessions. We'll start with automating web application security hacking. Then we will talk about a bit crypto and how we are using crypto and security frameworks and tools, which Shiran will elaborate on that. We will have also the mindset of the business and how we can perform a business penetration test from the business perspective. Not just we are protecting something. We as a security professional, we are not protecting ourselves, we are protecting our companies that are working and we are working for them. But from a business point of view, we actually need to protect the business. And there is a lot of things that could be done even before an event is happening, a security breach is happening, for the mindset, for starting from the mindset of the business flow, understand the business and understand the security. And then we will wrap up with ransomware awareness, how to become ransomware ready, which will be led by Omer. Omer actually prepared also a nice demo for us, which will elaborate on this topic. So without further ado, I do want to invite Alex, who is from Pentera. He is the head of research with a lot of research background. I assume he will dive into the automation of web application testing and will tell you more about this specific topic. So Spivy, the stage is all yours.
Thanks, Leo. Hello, everybody. So my name is Alex. I'm the head of research at Pentera. And what we do at Pentera is in the research team, we build on top of automation platforms, we build various attack vectors and attack infrastructures that interchange data in order to create automated penetration testing experience. One of the platforms that we've added in the past year is the web attack platform, and I want to share our perspective on this platform and to show that maybe web application is, it's a huge domain in the world of hacking, but using automation, even the most experienced pen tester can benefit from automation, because the automation will help finding the low-hanging fruits. It will help to find, to do very tedious tasks, but give a lot of value in the penetration testing process. And I think that automation will never be able to replace, an experienced pen tester, but automation can assist in making the time of the pen tester to be used to a good value. So the proposed approach in the domain of web applications is, first, once I have a web server and I have the application, I will describe the main phases. The first phase, create a crawler. You need to, and I will elaborate, but crawling basically means learning from links and smart guessing the various routes of the web application. Then the next phase is to derive attackable assets. And when I talk about attackable assets, it means that when you get the web page and you get all the parameters and get the responses and get all the metadata and the headers from the server, etc., you want to extract the bits and the pieces and to put focus on specific pieces of information that can help propagate the attack. And this is basically phase 3. What are the ingredients in order to establish this type of automation and to achieve those 3 phases? Have the Firefox or Chrome installed on the pen testing environment. Have the web driver for the corresponding web browser, and basically the web driver is It's a local server where you can control it, and the web driver interacts with the browser. And I will explain why using a real browser and a web driver is better than using some sort of HTTP library like requests. We are also using Selenium client. Selenium is basically used for QA automation of web apps. We are using it to automate the penetration testing scenario. And of course, Selenium, you have support in your, your favorite programming language or scripting language. And because we're using Python, we're using Selenium Wire, which is an extension to Selenium, and it gives us the ability to inspect the requests that are made and also to investigate the response in terms of parameters, headers, etc. So phase one is the web crawler. So the goal in this phase is to discover web routes, okay? And how do we discover different types of web routes? You can start with the main landing page and start clicking. And because you're using Selenium, you're basically clicking on links. Start clicking on links, and you click a link, a request is sent, you get the parameters, you get you get all the headers of the response, you have the body of the response as well. Keep track of those, okay? And of course, my recommendation to you, limit yourself to the scope of the tested domain if you're using it externally, because in each web page you have references to other to links, for example, images that leave the domain of the tested application or the IP address of the web server itself. And make dictionary-based access, because not every route that exists on the web app is accessible through links, like, for example, administration pages, etc. So once you've mapped the existing paths, you can append, do a guessing and add, create a whitelist of possibilities like PHPMyAdmin or the WordPress admin webpage, etc., and paste it to existing route and test those as well. If the hit is successful, great. Now you have another route. If not, it's automation, so it didn't cost you anything. Track records of every type of information, which method you use, get, post, the URLs, the parameters, the headers, the body, and of course, keep track of the response. Now that I've mapped, maybe I haven't mapped all the possible routes, but we did a pretty good job. Now it's time to derive attackable assets. And what does it mean, deriving attackable assets? A few examples. So in our asset analyzer, for example, one of the first things that I want to extract, I don't want the whole page. I don't want all this messy HTML. I want forms. Okay, I want to extract forms because there are many types of forms, and forms, from a pen testing perspective, it's a way to interact with the server. To attack something, you need to interact with it. So the most important thing, forms. You will have login form. We will talk about this use case in a few slides. You have file upload forms. Once you extract the forms, and extracting forms is very easy, especially with Selenium, when you're scripting it out. Once you have all the forms mapped, you can later say, please give me all the forms. I want to try to interact with the server, and forms is one of those ways. Supporting technologies. Once you have the requests, for example, you can use Webalizer, the dictionary Webalizer, and maybe you have this extension in your web browser that gives an icon of all the existing technologies like React or WordPress or something like that. This can help you with understanding if there are common vulnerabilities in the supporting technologies of the website in question. And during my talk, I see a question about CSRF. I will talk about CSRF in the form in a few slides. Error pages. Error pages are great because error pages is when you send a request, it said, hey, the database didn't react so good with the request. Here's the error, some SQL error, etc. Those types of error pages, which are indicated by a response code of 500, between 500 and 600, it's a great mean of creating cross-site scripting, reflected cross-site scripting attacks. And of course, you can map non-JavaScript HTML, CSS, PHP files. I mean, not web-related files, because hey, if for some reason I find non-HTML, not web page related file type, maybe it's an Excel file, maybe it's a Word file, it's worth looking at it, because it's now maybe it's not an anomaly, but it's something weird and something that not usually exists on the web server, and it's worth looking at it. And sometimes you may encounter access, Microsoft Access database file, and so on, administration pages. And now let's talk about attack propagation. And attack propagation, there are many attack propagations. What does it mean, attack propagation? It means, hey, I found some interesting asset. Now I want to take this asset and I want to create an attack because we're using automation. Okay, so there are many types of attack propagation. Let's talk about, hey, now that I have the forms, I extracted all the forms, I want to create a scenario of brute forcing the login page. It's one of the OWASP categories for web attacks, brute forcing. If you have some default accounts on the login page, and you have a dictionary of usernames and password, and you want to check that, hey, my website is not prone to common username, password, and so on. Let's call default creds assessment. So first thing, I have the forms. How do I find the login form? Okay, so once you have a form, first of all, you can look at various types of the input, and because maybe this can be like a talkback, a comment to an article form. But how do you know that the form is a login form? One of the best ways to understand it, and a quick win, is if you see a field which indicates the username, great. But this can be a username, username in uppercase, or maybe even not a word in English. But if you look at an input type of password, where the password is black dots hidden, it can give you a good lead and good assumption algorithm, a good heuristic to say, okay, in a form where you have an input type password, chances are that this will be a login form. Okay, so and now let's talk about, okay, but if you will look at the form and you inspect the form, for example, with you will look at the raw HTML. Sometimes in form you have hidden fields. You have many hidden fields, even CSRF. And CSRF, if you're trying to create automation with a library like requests from Python, you need to take into consideration all the hidden fields as well, okay? Because you are in charge of filling those fields. But because we are using Selenium with the WebDriver, basically it's like interacting as if the user is interacting with the login page. Me as a user, when I look at the login page, I don't see the CSRF field because it's there. And when I'm working with Selenium, I need to fill only what is visible for example, what will be visible to a real human, okay? The Selenium library allows me to iterate on fields of a form and ignore hidden fields, which of course, a normal human being won't have to interact with those. And this is why the CSRF field is preserved with the value that the server gave you, but it also will be sent as if you are filling the form in a human manner. Okay, so let's talk about other fields. So maybe there will be fields which are not hidden, okay? But you need to fill those as well. I don't know, maybe you will have a field of email. maybe you will have a field of date, and for some reason, it's a login form, but for some reason you have a radio button that you need to choose. Okay, so I'm not talking about creating an artificial intelligence mechanism to understand what is the semantic there, but you need to fill something. Okay, so in this case, if you have non-hidden input types, basically just, for example, in our automation, and this proves itself very well, we created callbacks, and these callbacks iterate on a login form on every field which is not hidden, and give some, for example, if it's a date, we'll give a random date. If it's a checkbox, we will, because checkbox you don't need to fill it, we will leave it blank. Radio button, we'll select one of those. And now the problem is to find the submit button. Again, it's a challenge, because sometimes you may have multiple buttons, and sometimes you have code obfuscation for the client-side code. So how do we find it using an automation? Again, it's not a bulletproof solution, but when you're creating an automated platform or automated tool, even if it helps you 90% of the time, it's great. Even if it helps you 70% of the time, it is great. And most of the login forms in this exam are basically the same. And how do we still handle the case of the submit button? So if the type is submit and it's not obfuscated, then great, it's easy. And most of the time in the form, you will only have one button, okay? So you can log in by clicking this button, okay? Even if the type is not submit, but most of the time it will be of type submit. So this is the proposed heuristics. If the type submit, click it. If not, and it's only one button, great. If you have several, then we choose it randomly. So, and now the tricky part. I'm doing a brute force. I have my dictionary. How do I know if the response, if the credentials that I've sent, how do I know if they are valid or invalid? This is the most important thing. So, in the most early heuristics, okay, let's check the return code that comes from the web server. But today, every web server for every login, even if the login is invalid, gives you a return code of 200 or some redirect. Then you cannot base your model on top based on the HTTP return codes. So what we are doing, first thing, we establish a baseline of an incorrect login. We generate a random username, we generate a random password, then we send it, and then I get the response I know for sure that this is the response for incorrect login, because I generate some gibberish for the username and some gibberish for the password. Now that I have the baseline for incorrect login, I can start firing up username, password, username, password, username, password, and then I compare the results based on the baseline that I have for incorrect login. And we're doing a text-based similarity, and we know if the response is very similar to the incorrect login, and if you're doing, for example, text-based similarity, you have the Levenshtein distance. If you're rendering it an image, you have a bunch of image comparison libraries. If the result is similar to the incorrect login, set a threshold, for example, 90%, you know that those credentials are incorrect. But if the similarity is very low, for example, below 30% or below 20%, then you can assume that, okay, these credentials gave me a page which is very different from the login page. And our assumption that these credentials are probably correct. So by doing this, and you can find if you have a login page which is prone to default credentials of some sort. So what's next? For example, now that you have the credentials, you can start the process of the crawling, okay, but this time only authenticated. Do the login, and now that you have the session cookie, you can send the session cookie. Now you can have authenticated crawling. Just a recommendation, be sure that you're not running on, I don't know, some sort of web app for managing nuclear missile launch, because when you're doing authenticated web browsing, it means that you get some sort of privilege. And our tendency is to be very, no, it's very risky to do authenticated crawling, and it needs to be taken with care. So only if you know that this is such, the application is not mission critical, proceed to authenticated web crawling and start collecting more routes. Okay, let's talk about another sort of attack propagation I mentioned before, reflected XSS. Reflected XSS is where you engage in a user to hit a link. The user clicks the link, and the response from the server forces the client of the user to run some code on the client side, on the browser of the user. Okay, so how does it usually works? You send a request, and you fill some values into the you fill some values to the parameter, to one of the parameters in the web route. The server processes the request, and based on the parameter, maybe the response, the HTML that you will get, will have some rendering of those parameters. Okay, and then you can play with the input and to make the input basically a script. Okay, how will it work? I will say, okay, to my engine, in the crawling phase, I mapped all the types of requests that I have. Okay, please give me all the GET requests and all the corresponding parameters. Okay, okay, so now I get all the requests. I have the path. It should be a GET request, not a post. Sorry, typo. I get the path and the params. Okay, so now I'm sending to the server the path. I'm sending, and I fill some random strings in each type of the parameter. Okay, random string like some sort of UID, for example, ID, and some sort of string in the name. And then I know that if the server, if in the response I will find random string 1 or random string 2 in the response, that this server may be vulnerable to reflected XSS. And then one of my inputs, I can put in the link some JavaScript code. And then if I will send it, and if I will send this reflected XSS, this link, I will send it as a phishing campaign to in a mass phishing to a big list. And if somebody clicks on it, I will be able to run JavaScript code on the browser of the victim. Okay, so this is, for example, one thing that you can do. Okay, so but now it was very abstract. If you're using in your web penetration testing, you use some known tools for finding XSS vulnerabilities like XSSor. One of the parameters for the XSSor, okay, because it's a Python tool, so you can use it in your automation. You don't need to write this example that I mentioned before. If you're using some sort of open source tool for testing XSS vulnerabilities, the input for running the XSSor is, okay, please give me a URL with parameters. And then the XSSor will try to find all sorts of XSS vulnerabilities, not just reflected ones. So by extracting all the GET requests and the parameters and sending and pipelining those into the XSSor tool, you will be able to create an automation that integrates with the pen testing tool that you are using in your engagements. Let's talk about another type of attack. Again, it's very easy to automate the lead that will help me achieve this type of to discover this type of web vulnerability. What is basically a deserialization attack? A deserialization attack, serialization means that, okay, I have a backend object, some sort of Java object or a .NET object. In order to save this object, I want to turn it into by a stream of bytes. Okay, and then I save it in a file or a database. And when I want to load this data and to turn it as to a Java or .NET object in the memory, this is called the deserialization. What is basically the insecure deserialization? Insecure deserialization means that when I'm sending the web app a very crafted request, maybe one of the fields that I'm sending will be turned to a Java object, and then the Java code will do something with this object. Maybe if I send a stream of bytes, it will eventually in the server will turn to a .NET to ASP.NET object, and the system will run it. And in some cases, turning this code turning this stream of bytes into an object, and when it starts the integration with the native code of the Java or the ASP.NET, maybe it will eventually execute as a function, will eventually execute as machine code the object that you've sent. For sure, it wasn't the intent of the writers of the application, but this is exactly the vulnerability. When you're crafting a specific field, you're sending a stream of data, and eventually, instead of turning to an object which is used for display or some sort, you're writing it in such way that it gets executed. Same example as before. Please give me, you want to get the request that you've mapped, okay? And in this at this time, the parameters doesn't matter. Why is that? Is you send the request to the server, and if the server, for example, contains in the response contains the strings view state and value, basically it means that you can use this field, and it may be vulnerable to the ASP deserialization, because you will be able to send this data as an object, and this data as an object, if it's crafted in a specific manner, will be translated by the framework like .NET and will get executed. Okay, and how do you do it? Again, once you've mapped the request and you know that, okay, this request may be prone to the ASP deserialization, and there are all sorts of ASP deserialization, one with verification, the other without verification, with default keys or not default keys. And there are many articles on how to branch out, but they are all exploitable. You will need to add to the request a tempered view state. A tempered view state is basically the stream of bytes that will be rendered on the server and will be executed. What is this tempered view state that you will send? There's an open source project which goes by the name Serial. Serial helps you add your payloads, helps add your shellcode, for example, or your command lines that you want to execute, and wrap it in a managed code stream of bytes. So you will only give Serial this project. You will get, okay, so I want to execute PowerShell, invoke web request, download and execute, and it will wrap it as a .NET object that you can send with the injected view state. What do we do next? For example, in our platform, you are able to run code. So you want to test the impact. Okay, so you can execute code. My app is vulnerable to running code on the server. You want to investigate further. You want to say, okay, what is the potential risk? If the web server is running on a low privileged, if the web server is running in low privilege mode, then maybe that's okay, still a compromise, but maybe the risk is not high. But if the web server is running admin level or something system level, then you may run payloads like Mimikatz or some sort of more aggressive payloads that can give more value to the attacker. If it's low privileged, still some harm can be done. Traverse on the file system and look for accessible files, and maybe there will be interesting data there, or deploy some privilege escalation payloads, which will help you to get from a low level user, low privilege user, to a high privilege user. Questions?
Okay, so guys, if you have any questions to Spivi, please write them down in the chat. There are some questions. Let's start with the first, Spivi, regarding, there is a question, what if we have a CSRF token on all forms? Does it, I think, interfere with the test that we are doing? Might it stop the attack automation?
Because if you're using a library like requests, then yes, because you need to handle this field, and it's up to you to fill it, because it doesn't remember, it's stateless. It doesn't remember what the website gave you, and you basically ignore the return CSRF. But if you're using Selenium and the web server gave you some value for the CSRF, it's exactly like you are filling this form. You leave the CSRF token as it is, because it's a hidden field and you don't change it. You just fill the username and the password, and all the other fields that the server gave you are remain intact. So basically, if you are filling the form with Selenium, you preserve the CSRF token, and this shouldn't be a problem.
Mm-hmm. Okay, there is another questions. Let's see.
If you have Ajax calls.
Yes, yes.
Okay.
Kunal, what if form operates on Ajax calls?
Okay.
How we can automate the same?
Okay, so how do we do this? I didn't mention it here, but again, when you start building the automation, you encounter more and more scenarios, and Ajax calls is something that exists, or you have dynamic web pages that generate requests, and how do you capture those? What we are doing is we've set up, I've mentioned two methods to derive routes. One of them is traversing the links, and the other one guessing. There are more ways to collect routes. One of them is setting up a proxy server, okay, where all your requests that generated from your penetration testing browser are redirected to the proxy server, and the proxy server is your component of code. So when the proxy receives it, this is also a great way to collect routes which are transmitted from the client. For example, Ajax calls. So if an Ajax call is made, it will hit your proxy server, and your proxy server can direct this one as well.
Mm-hmm. Okay. There is another question coming from Arangel. I hope I pronounce it correctly. What do you use for trying different payloads? Nuclei templates? Like if you are trying to use different payloads.
So Nuclei is a great platform. It's written in Go. It's very fast. Okay. Specifically in our platform, we don't use it. Okay. But do the pattern matching of requests and analyzing the response. You have, for example, it does it. It generates the request and says, okay, if in the response you have this type of string of this type of pattern, you are vulnerable to. So Nuclei is a great solution, and I recommend using it. We are not using it due to some other restrictions, basically, because of the software that we are working on, the existing software and the existing automation platform that we're working on with. But Nuclei is a great solution, and the concept of doing fuzzing various types of data to given route and placing various types of fuzzing the data and different parameters, and then checking the response and saying, okay, if you have this substring, then you're vulnerable to. This is an inspiration from projects like Nuclei. And by the way, it's very fast. The implementation is very good in Nuclei. And basically, we're continuing to create something in Go because the performance of Go is better than Python.
Okay, so I think there is No further questions. Guys, if you have any questions, write them down in the meeting chat. We'll also keep time in the end of the meetup if there will be more questions. So, of course. So, Speedy, you want to summarize?
Yeah, of course. So what I've mentioned here is how we're using QA automation frameworks to derive attackable assets from web application, and I recommend using those ones because it's easier than for you using HTTP libraries and analyzing the data yourself. The QA automation of Selenium helps us a lot and helps us to retrieve data very easily. Attackable assets give you low-hanging fruits, and by the way, you can inspect not just XSS or deserialization attacks. You can check you can investigate SSLs. Okay, if you can check your certificates. You can check for stuff like, do you have comments in your code with, and then extract comments and then say maybe some programmer embedded some comment which shouldn't be there, like for example username, password. There's all sorts of attackable assets, and basically they are the low-hanging windows, gateways to something more major. Then take the attackable asset and try to attack it. Maybe write your own automation or throw it into SQL maps, XSSor, use it with nuclei, because these tools, they need, their input is not just, hey, give me a website and I will check for SQL injections. Give me a form, give me some sort of route and parameters which I will use to play. And this phase of deriving attackable assets is a great feed for very known attack tools that serve the web application penetration testing community. And it's like a cliche, but try to create automation for, if you're doing something twice, try to create automation for it, because if you did it twice, probably you will encounter it on your 4th engagement, 10th engagement, and always fine tune, because the Ajax example is a great example, is where we created something, we did this automation that I mentioned in the slides, and then we saw a request made by Ajax or some dynamic content. And then, okay, so how do we deal with it? We didn't say, oh, automation sucks, it's not good. We said, how can we upgrade the existing automation to capture more types of requests? Okay, let's set up a proxy server. Now this constellation, this setup serves us in all of the web application testing. And we keep enhancing it and add, of course, we miss stuff, but we learn what we've missed, and we don't give up on automation, because automation is the main issue. We try to improve it, and it finds a lot of stuff.
Okay, Svivi, thank you very much. It was an insightful lecture. I learned a couple of things that I didn't learn. Didn't know. Just one last thing, Svivi, I can see in the chat there, Murat asked, can you tell once again what was the serialization tool that you've talked about?
I can answer it live.
Yes, right in the chat maybe.
I will type
to all in the chat, in the type, so that will be great.
Did everybody got it? I will write in 1 second.
Also to post for everyone in the chat, it will be great. Okay, so thank you very much, Pivi. And I want to also invite Shiran Kleiderman, who is actually a colleague of mine. We know each other for more than 10 years, something like that, maybe a bit more. Shiran is actually the CISO of Celsius, and it has 18 years of experience in application security. I know him from the beginning. He's a really hands-on, very experienced security application guy, did lots of projects in Israel and abroad, so he's very known in our industry, and also in the security consultant area, but now he's the CISO of Celsius, so he's doing a great job over there, I'm assuming. So, Shiran?
Yeah, thank you, Lior. Thank you for having us. Yeah, myself and Celsius. Yeah, we have a few participants here, so that's good. Those are the guys that are asking the questions. One of them. So yeah, again, the foundation is crypto/cryptography, cryptocurrency and cryptography from the military, and then from the private sector, dealt really mainly with cryptography and everything that's connected to that. in the public and private sector, cyber intelligence, a lot of investigations here in Israel and abroad in the US as part of 2 companies, K2 Intelligence and Blue Voyant. And at Celsius for the past year and 8 months, 9 months, something like that. Again, we're going to talk about the decentralized finance, the crypto space, which is here. It's happening now. Not a year from now or not 2 years from now. So this is really a hot industry and sector for all security, financial, infrastructure topics. We'll talk about a lot of them again. So not only application, of course, infrastructure and how you protect digital assets, and how you interact with clients and institutions, and we're going to talk about it. So before we go into the threat landscape and to the security solutions, we're going to talk about what is DeFi, decentralized finance, what is crypto even to some sense. So first of all, the analogy here shows that really the current financial system with all the big banks and fintech and high frequency trading and everything, and amazing systems, but at the end of the day, they're very, very centralized, and you could say that the whole system currently is based on Excel, and we're not even, exaggerating. That's the thing. And with crypto, the shift, if we keep this analogy, the shift was to move from Excel, to Google Sheets and Google Docs, you could say, and then Google Sheets and Google Docs on steroids, meaning creating something that's very, very transparent, very, very immune to attacks, something that can just evolve and create a revolution within the current financial system. And this is exactly what DeFi and also CeFi, centralized finance, we'll talk about that. This is what it does. So really a few points about decentralized finance. You see it here. Both the centralized Web 2.0, which has a dealer, a middleman, or a middle person, the decentralized Web 3, and that's you could say the tech term or the slogan for it, doesn't have a dealer. It's not centralized. It's very distributed. It doesn't have one point of failure. And it's based, as you see here, on blockchain technology, cryptography that's tested. I do want to point one specific topic. Crypto is relatively new, the applications, cryptocurrency and Bitcoin and Ethereum and the rest, but the foundation is 30, 40, 50 years old, and tested. And those are the cryptography primitives, you say, from hash functions, digital signatures, encryption and such. And that's why it creates such a robust, and safe and secure environment. And you could say that the bottom line is that Bitcoin, its blockchain and such, hasn't been hacked, since it was created. There were business logic attacks here and there, again, like in every sector, every system. But the bottom line, this network hasn't been hacked, and it's just up and running, since it was created. The transparency, like we said, is key. We'll talk about it more. The math part, that's a cryptography. Protocols, we'll talk about that. Again, protocols that are connected, and you create chains of protocols and chains of operations which are complete and safe. And from the human or from the people perspective, it just gives access to financial services, banking or new banking services to people that till now were unbanked. They didn't have access to the current financial industry, or they didn't want to have access or connect or be involved with the current financial sector. And this is important, giving this access, giving the unconditional access. You can move to the next slide. So really, what decentralized finance at the end of the day does is take the current financial instruments that we all know from Wall Street and other markets globally, and it just puts them in a secure, transparent, auditable way on these blockchains. So you could buy crypto, you could earn rewards or yield on assets that you stake or that you put in various services. You could take out loans, you put crypto collateral, then take dollars or take stable coins or other types of crypto. You can swap between coins. And the key point here is that you take things that have been in Wall Street and they didn't favor, you could say, us, the clients, meaning when you put money in a bank today, you get zero interest, give or take, 0.1. So that's irrelevant in this day and age. Again, you pay the banks to hold your money, and DeFi changes the equation and improves this. Now, again, if you have any questions, feel free. We can answer now, after, so feel free. So when we say DeFi or dealing with cryptocurrency platforms, there are various ways to go. One of the things, or one of the applications you could see here today, this is a specific application. Again, see at the bottom, again, we're going to talk about finance. We're going to talk about assets and digital assets. This is not financial advice in any way. With that, again, this is already happening. This is already a lot of people, millions and more, are participating, and billions of dollars in assets and digital currency are deployed to these platforms. So when you say a DeFi platform, this is an example one that you just go to their site. Go one slide up for a second. You go up to their site and you connect your wallet. Your wallet could be an online wallet, could be a ledger, a physical wallet, and such. There are various types of wallets, cold, hot, online, warm wallets, and such. And there's no login here. There's no authentication. The only authentication is a cryptography-based authentication with your keys that are held in your specific wallet or in the seed phrase and such that you remember, that you save aside. And then you can already cryptography-based interact, do the operation that we said before, borrow money, deploy assets, and gain yield, interest for them, and such. So today there are hundreds of these. We'll talk about doing testing, due diligence, again, not to fall for fraud and such in these platforms. So go. So in addition to the mobile or cold wallets or DeFi platforms that are online, this is another example of a desktop application you download, and then you fill it up with specific coins. Here specifically, this belongs to the Cardano network, and then you can stake your coins. It helps secure the network, and for this operation, this staking operation, you get yield, you get interest in these coins. That's a reward that you get. So this is another desktop type application. Again, the crypto is very, very solid here, but when we do testing and such, and we'll talk about some of the risks, of course, there are growing pains of business logic attacks and application security, and you could expose secrets and other things that we find when we do the diligence, which we'll explain and give a few examples. So again, same as in the regular industry, just a lot of new financial instruments, a lot of new platforms which need testing, which organizations like us, Celsius, and private people, good to do due diligence, good to do the testing, monitoring, understand with what you're interacting. Let's move on. So before we talk about more solutions and such, again, the pitch here, you could say, is really from centralized. We went to Web 2.0 and now Web 3. You could see the evolution and the revolution from Excel-based systems, give or take, to the cloud and mobile and web servers, and then to distributed systems, blockchains, file systems, which are split and distributed peer-to-peer systems. This is the shift. And again, this big whale or big fish is slowly eating, you could say, the smaller ones and the older technologies. Some are being, of course, adopted to this new distributed world, but a lot are being left behind. So as a company, and this also, it starts to answer the framework question that was just posted. As a company, when we define the decentralized finance, security, and crypto frameworks or security, we need to be the best at all the topics that you see here. We need to understand all the types of blockchains, layer 1, layer 2, the various networks that are being brewed and deployed at the end of the day. We need to understand the types of coins. We need to be professionals on the blockchain, coin deployment, distributed digital assets realm. Then we need to understand what cybersecurity, intelligence, the legacy things that we all have been working on for the past 10, 15, 20 years. We need to understand cryptography. And like in any sector and any topic, and again, this is hot in cybersecurity and others, we need to understand asset management. So instead of managing servers and devices and such, we manage the digital assets, how they're deployed, what yield or money they're making, on which platforms are they, in which strategy they're deployed. Again, a lot of technical financial things that we may get into, but bottom line, you need to understand where your assets are, in addition to where your devices, blockchains, wallets, and keys are. So asset management talks about assets themselves, talks about keys, talks about servers, talks about other technical assets which contribute at the end of the day to your attack surface, internal, external, and things that are deployed. And these also talk about, again, you see here, transaction monitoring, we'll talk about that a bit, anti-money laundering, that's compliance, security code scans. A lot of things are legacy things. Some have adopted to new languages or languages that's specific to blockchain technology like Solidity and such. And again, we adapt the new technologies with new, or you could say old techniques. Yeah. So this is really the balance. We need to be balanced on all these topics. They need to be green within our framework, and we'll talk about other topics that stem from these, but we need to be good at these. Celsius as an organization, yeah, we're not a bank. We're a financial institution that deals with digital assets. This is give or take how we're built. On one side, we're centralized finance organization, meaning we have regular databases and regular mobile web apps, transactions and stuff, ledgers. And on the other side, we're a decentralized finance organization. That's the more purple pieces that you see here. So we have to deal with both. We have all the relevant security controls, endpoint protection and API security, VPNs, cloud security, and more, SIM systems response. And we need to understand, again, how CFI, centralized finance, legacy banks, or institutions, and again, we're not a bank, work, and how these decentralized finance platforms that we saw before, and we'll see a bit more, how they work, how to interact with them, how to secure them, how to do due diligence on them. That's our goal. And one of the things, again, cryptography-based that we emphasized here, that's called multi-party computation. At the end of the day, that helps protect assets at rest and in motion, because in all these arrows, in all of them at the end of the day are bilateral or bidirectional. You need to control the flow of funds. You need to control the flow of assets. And multi-party computation at the simplest level says that in order to move crypto, 2 people, 3 people or more, a specific quorum or a defined quorum need to sign on the transaction, similar to what you see in the movies, but more interactive and more technical and integrity-wise, when 2 people, in order to launch the missiles in the submarine, Denzel Washington, another guy, most of the times, they need to meet and connect their keys, yeah? So this is what secret sharing or multi-party computation is, just at a higher scale, a lot of transactions, a lot of signing, yeah? And at the end of the day, in order to move assets, you need to digitally sign some kind of message, yeah? And that's done in a distributed way, meaning the keys don't reside in one place. We can move on. So when we look, and this is again part of the framework and everything, when we look at the key security risk, the first thing, like we just mentioned, is crypto key compromise on our side and also on the DeFi platforms, on the various blockchains that we interact with. So in order to deal with that, distributed or non-existing keys at the end of the day, that's the secret. Coding errors, security vulnerabilities, same give or take as the current market, what was described till now, just in different contexts and different languages, yeah, at a different scale, different maturity at times of products and services. The next 2 points, this brings in financial expertise. At the end of the day, you need to have financial people, accountants and such, or people that understand trading, and how the markets work in this sector on the blockchains in order to find these business logic errors or business logic bypasses or financial mistakes that exist or are inherent in the various protocols and such. So in addition to technical people and good cyber people, good cyber intelligence and such, like I said, asset management and accounting people or trading people, professionals that understand how money works, how crypto and digital assets work, and to see if there are any manipulations in protocols. And the rest of the things, again, very, very similar to what we have today, misuse of third-party libraries, protocol systems, and within these platforms, we'll give a few examples now. Really, a lot of them are just not transparent. They say they're distributed, but not. They don't do security tests. And then when you put your assets there as an institution like us or as a private person, you need to understand, is this platform tested? What have they validated, if at all? And this gives you comfort and such. Move on. So we'll talk about a few attacks, and then we'll go into more solutions. Attack that happened recently. Here specifically, 60 million, you could say, dollars were stolen at the end of the day. And the thing here was that the smart contract, that's the algorithm that defines how their network, how the coin and asset interaction, which coins exist, how you withdraw, where you put them or deposit them and such, that was hacked, and additional functions, were added, or here specifically swapped, functions that create new tokens or functions that burn current tokens. They were swapped with malicious functions, again, same as the functions you'll have in the regular world, just for crypto and financial operations. And the goal here, or the attack vector more specifically, is that probably the attacker stole the administrator's private key, the paid network private key, which probably wasn't distributed or sharded and secret sharing methods and such, and that created the exploit in the network and the swapping of the functions within the smart contract. So this is an example attack. Again, we'll talk about some of the due diligence in a second. Move on. Another attack vector that we see, and this is part of the audits that we do, get to know the various platforms, get to know the players, any report or audit report. And again, in this world, transparency is key, meaning every platform that's launched and similar, the key ones, they present, they display. I did an audit report, security audit by a known firm and such. This is my badge of honor. It's important, So some of the trends that we see, because there are a lot of platforms that are launched here and there, and we'll see more examples in a second, some present fake audit reports. So this is another thing that you need to be aware of and not take as a private person, and also as an institution like us, or as a company that serves institutions, not to take anything blindly. Understand what you're looking at, read the reports, understand who did the audit and such, and advance that. So one of the things that we see a lot, and this is part of the security testing and checks, and also the due diligence that we do, again, as a company like us, and also as private people. A few months ago, there was this trend, and it's still happening, that a lot of the code here is open source, if not all of it, and people can just launch new DeFi platforms and new exchanges or new distributed exchanges in 10 minutes. They fork the code and then launch the operation. So there were a lot of distributed exchanges or DeFi platforms at the end of the day on the Binance Smart Chain, that people forked each other's code. They didn't change specific parameters. A lot of the code wasn't tested. And then there was this wave of hacked decentralized exchanges or DeFi platforms that just stemmed from the same code that was reused and reused and reused, or a subset or example platforms. And then this caused, you could say, a lot of noise, in various sectors within the crypto sector, about such problems. Again, these are things that we avoid. These are things that we don't deal with even. Yeah, super important to do these tests and such. So some of the key security controls and activities, and starting to answer more and more of the framework question. Again, we use the regular and known security frameworks such as ISO and NIST and NISA and Cloud Security Alliance and more secure development lifecycle. We use the common ones, we merge and we mix and match, so we have something that's ideal and relevant to us and also strong. Yeah, it all starts, and this is something that you hear all the time, do your own research, yeah, before you deploy assets that you will lose, yeah, maybe, yeah, that you're willing to lose more specifically. Do your own research, do your due diligence, that's the key thing. Mostly non-technical due diligence, meaning who are the people that you see here at the end, who are the developers, have they done audits, how's the security posture of their code, how's their GitHub repository, how's their community. You can know by the size of their Twitter group or Discord group or whatever, if it's legit even, yeah. If there are 10 people in a Discord group, you won't put your money over there, for sure. Yeah, that's a pro tip, as you say. And then you look at other topics. Again, do they support key sharding, crypto key security? Do they do security testing, monitoring? And we apply these things as well, of course. Yeah, we verify and add MPC, multi-party computation. We do testing and ongoing monitoring at all the levels that were described here even before. Yeah, application level scanning, infrastructure, all the due diligence, technical analysis that was mentioned here before, and more. Okay, so that's that. Two more points regarding two specific examples regarding the framework, and then we'll go to questions. When we talk about pen test, attack simulation, risk and remediation orchestration, again, like any company that has internal full-time employees that do penetration testing and such, bug bounty, consultants, these three pillars are very, you could say, we invest in them and very extensive, and specifically also bug bounty. Some is real, some is fraud, of course, but bottom line, we utilize these three pillars as much as we can. Internal pen testers, bug bounty, like I said, consultants, we use it really to the maximum in order to measure ourselves with the various activities here, PT, red teaming, attack simulations. On two pillars, the width of the pillars doesn't mean what's more important or less, but one, of course, on internal systems, product, services, integration, and then we have the whole automation of creating reports and opening tickets. I didn't mention the name of the system here, just throw System X. And it's very important to have this open channel internally with the developers, with the DevOps teams, with the product managers and more, and have this remediation orchestration because we do a lot of testing internally. And same for the external systems that we deal with, vendor systems, the DeFi platforms, understand the findings, create the reports, create the due diligence. A lot of times there's no one to send the reports to, even the DeFi platform specifically. You may send, but they'll look at it, maybe they'll fix, maybe not, depends. Some we know less, but that's a different story. So these are the two main pillars that are key to our security program, to any security program here specifically. And again, the vendor system, DeFi platforms, very, very integral part of what we have and what we need to test. Like I said, with the whole army here above, really, the FTEs, full-time employees, bug bounty, consultants, and others. Yeah, again, anyone from the community that may raise problems and such, super important at all levels. Yeah, so that's one example. And another example, can move on. And another example, and this is more at the blockchain specific, transaction and anomaly detection. The data science part is, like I said, when assets move, when people interact with blockchain, when people try to defraud us and stuff like that, again, internally, externally, this is the key thing. Monitoring the transactions, instead of monitoring the HTTP, HTTPS, or web interaction flow in order to understand who's trying to knock out or knock off or whatever the server who's trying to intrude. When you look at these DeFi platforms, when you look at various wallets, internal and external, and you analyze the types of transactions, you understand about if they're legit, less legit, how important is it to raise an alert and such. So here specifically, we're talking about an operation that could be external on DeFi platforms or internally for our clients, coin swapping. And the point is to have very strong data analytics, data science that humans, of course, can't analyze when a person does multiple loans and then multiple inbound transactions, outbound transactions, and then the swap in order to create fraud. Here specifically, you say margin trading, meaning they buy for X on one place and on our platform, other platforms sell for Y, and then make this arbitrage or delta. These are types of fraud, anomalies, automation, bot automation to see how many inbound, outbound within, you see here, 24-hour time span and such, how many transactions are made. And then we also understand, is it a human? Is it an algo trader, you could say? Is it a bot? And then we analyze the risk. We have various scoring methods. And then we really can highlight internally for our system, for our network, and also for the DeFi platforms that we work with. Is it legitimate? Is it less legitimate? Something that we should block and such. Okay, so that's an example. And that's that, yeah. If you have any questions.
Okay, so first of all, very interesting topic. I heard somewhere, Shiran, that another side of innovation, the other side of innovation is security and cybersecurity. And I think here in the blockchain, I think the innovation and security are starting to become as one. Like in the blockchain, all the new encryption size. So it's a new field, a new innovated, and when there is an innovation, there is also always breaches and attackers that want to attack, and vulnerabilities, of course. And we as a security professional want to protect against those. I have a question actually, Shiran. As part of your work, what will be the most common attack on blockchain infrastructure, or do you see any trends in these vulnerabilities or kind of attacks, or what you will recommend to start with, even in order to protect the process?
So before I answer that, just a very quick point related to the innovation. We talk about a lot. Even today, we talked internally. We're not only in the business of defending. There's a cliche, security is a business enabler, but here it's really real because at the end of the day, we need to approve the new coins and new platforms and asset deployment and more. So security at the end of the day, very, very integral to the business. Regarding attack vectors, of course, for private people and also for organizations, how keys are managed. Okay, that's one thing. Security of credentials, security of keys, security of the secrets that protect assets. That's one thing. The second thing, it's more of a recommendation. When you go on Twitter, a lot of people have in their profile, I have Cell token, I have Bitcoin, I have Ethereum, I'm an ADA or Cardano groupie and such. Again, that creates or puts a target on your back, of course. So from that perspective, if you hold a lot of crypto, even a bit of crypto, keep a low profile, don't post it all over Twitter, because at the end of the day, if they won't get your crypto, they'll get to your banking account if you have anything there, because you spend everything on crypto at the end of the day. So that's a key recommendation. For us as organization, like I said, then it's connected to the Twitter thing, potential and protecting from account takeovers and such, and awareness regarding phishing attacks and stuff like that. Social engineering of clients and such, that's something that we invest a lot in, like in the regular banking sector. We educate about that, not to fall prey to various social engineering attacks and such, and not to click everything. And also, like I said, store credentials. Don't use an email, for example, that you use for 10 other services that may be hacked, to protect your crypto. So these are some of the basic things, But just to summarize, again, key security, that's key for sure. Again, using new and tested, and specifically tested algorithms, distributed key sharding, and security. That's one. And doing your due diligence, doing your research on the various platforms, because there's a lot of gimmicks out there, a lot of blinding lights, you could say, that, again, very sparkly. Again, it's like, this is the new generation of slot machines. Yeah, you get into a casino, everything blinks, you have bears and dragons and whatever, or Chuck Norris, and you go to what makes you tick. This is the same. This is the slot machine version of casinos, just on the web and such. So you need to be careful. Yeah.
Okay, thank you very much, Shiran. Thank you. Very insightful lecture, of course.
Sure.
We will have time also in the end of the meetup. The panelists will stay, of course, and answer your questions. So if you have any question, write them down in the chat. We will answer, of course, but in order to keep time, I want to proceed to the next lecture. So thank you very much, Shiran. Very insightful. Thank you. So I do want to invite Leah Tzur, who she's the CEO of LT Risk Management, a boutique consulting company specialized in cybersecurity within business process. She has more than 20 years in cybersecurity expertise in risk management, and she's also one of the common lecturers in Israel Academic Institute, and she will talk today about business penetration test coming from the business side, and actually even prevent from attack.
Yeah, also.
So Leah, the stage is all yours.
Okay, so hello everyone. My name is Leah Tzur. I'm very happy and honored to be a part of this meetup. It's always a pleasure to speak about new methods of how to manage the cyber risk, or in other words, the next generation of cyber risk management. I will do my best to speak very briefly in order to leave enough time to answer questions. Let's see that it's working. Okay, just a second. Yeah, we have a delay here. Okay. So I want us to go back to the foundations, back to the basics, to remind ourselves as the risk managers, as the cyber defenders, that what we want to achieve here. We want to be prepared for cyber attack, right? So in order to do that, we need to get into the attacker's mind, tracking their steps, understanding how they act and how they think, or in other words, in order to catch a thief, you need to think like one. And what do I mean when I say that we need to track the attacker's steps and get into the attacker's mind? We're all familiar with the concept that cyber contains people, technology, and processes. But what do we mean when we use the term processes? In most cases, in most organizations, the cyber defenders use the term processes as to technological processes. But is this the case? And what about the business processes? Are the technological processes the only processes out there in the attack chain? What about the workflow which humans, I mean the employees, go by? Not the machine workflow, not the network architect workflow, not the technological activity, but human activity among themselves, between them and their clients, suppliers, management, and so on. Let me tell you, cyber criminals recruit former employees, former business experts from the target business organizations they are attacking. The business processes are an integral part of cyber attack chain. We therefore need to widen our vision towards new cyber risk methods, new cyber defense methods within the organization. We want to find the vulnerabilities in the business processes. I have a hard time with the slides. We want to find the vulnerabilities in the business processes, in the business chain. We need to hypothetically dress up as an attacker and get into their mind and think. When the attacker, when the attacker gets inside the organization network, what will they do? How can they steal the money or the data or the detail of the data and so on? Remember, nowadays, we don't manage a cyber risk as a prevention state of mind, but we manage it as a fact that it's only a matter of time until our organization will experience an attack, and we want to be prepared for it. When you track your imaginary attacker, it enables you to identify the vulnerable spots, the ways and the steps that attacker will take advantage of, especially if there aren't any controls in their way, whether they are online controls or introspective controls. And we always need to keep in our minds that attackers also know how to delete the controls of the trail. When doing a business penetration test, we ask ourselves, where can I add controls that the attackers can reach or find them? Sometimes I add controls that involve human activity and not only systems, like picking up the phone and asking the user if they were the ones who performed the transaction. We need to ask ourselves what could be done in order to mitigate the gaps. Sometimes we change the workflow, sometimes we add controls, and there are a lot of additional creative and unique solutions to implement. In addition, those business controls can give us a wider view of what's going on during a cyber attack. By setting anomaly controls, we reflect suspicious activity that someone is doing something exceeding the normal behavior, whether it's the employee behavior or third-party behavior like client, supplier, and so on. Those anomaly controls enables us to see more clearly where the attacker had been in the network and what they had done. This precious information is crucial during crisis management. And after this long, it's like a game here. Just a second. Yeah.
Just be gentle. Just be gentle. It's taking.
Yeah, and I'm a woman. After this long intro of the business penetration test, I'm sure you're all anxious to hear about my personal background and experience. So I'm Liat Tzur, I'm the CEO of LT Risk Management, a boutique consulting firm which specializes in operational risk management, such as BCP, business continuity plan, and fraud and embezzlement prevention, and of course, cybersecurity in the business processes. I used to work at one of the biggest Israeli banking group, Discount Bank, as the head of fraud and embezzlement prevention and cyber risk manager in the business processes. And nowadays, I'm a lecturer in a number of Israeli academic institutions. After the founding event of the Bangladesh Central Bank attack, where the attacker almost stole $1 billion, we realized in the bank that focusing only on the technology dimension is no longer enough. We wanted to see what's going on in the business processes. For example, is there currently any user who is able to independently wire an unlimited amount of money or very large sum of money? And if not, could two employees do that, an unlimited transaction? Maybe we might be better off stopping a transaction under certain conditions. And now listen to this. This is a very important question. Can a technological person, a cyber expert, determine what those conditions will be? Unfortunately, the answer to the last question is apparently not. And listen to this. The technological people have a hard time communicating with the business people, which is exactly where LT risk management comes in. Yeah, no, almost. I want to continue by presenting an example of BPT deep dive analysis. In this diagram, you can see an analysis of one of the call center business process. And more exactly, bank call center process where a client wants to wire his money. On the diagram, you can see how the analysis refers to both the business dimension as well as to the technological dimension. That is a holistic view. It is essential for the process to be handled end to end. And in our case, the process begins with the client's idea that he needs to wire some money, and it ends when the money leaves the bank systems. Now, when we start to analyze the process, the workflow, we take it step by step. What are the channels? We ask ourselves, what are the channels that the client has in order to wire the money? For example, is there only a call center representative, or is there IVR system that the client can click on some buttons and perform the transaction? And in each and every step, we map the systems in the technological dimension and the employee's workflow in the business dimension. In the technological dimension, we ask questions such as, Leo, it's like the most difficult thing. Yeah, we ask questions in the technological dimension, like the security systems are installed, implemented, like firewall, NAC, IPS, VLAN, and so on. Does the organization have SDLC process? Is there any DLP installed? What is the network topology and configuration? Are there monitoring detection systems for privileged users? Are there a dedicated security system like SIEM? Is there any security operations center and alerts there? And in the business dimension, we ask questions such as what access level is allowed to the employee or to the IT team, and what can be done by the employee, and self-execution versus manager approval, and what is the maximum amount that the employee can execute. And a lot of the questions, additional questions that focusing on the business dimension. And then we look for back office and control units. We want to verify where there will be, they will notice any suspicious activity. Now we need to split our test into two separate tests. One, checking whether or not there are any actual controls that are relevant. And two, checking the controller's awareness, because having a relevant control won't help us if the employee who checks it doesn't know to whom they need to report, and that that this action, this suspicious activity, could actually be a hint of a cyber attack. I personally like to imagine the business process as a pipeline. After analyzing all the vulnerable spots and gaps, we now can recommend effective controls, and especially where they should be placed in the pipeline. So it was very briefly. I want to thank you all for listening. Yeah. I hope it was interesting and instructive, and you are welcome to connect with me on LinkedIn, where I publish articles and also share professional data. And I will be happy to answer your questions. It was shorter than I planned.
So no, that's okay. You know, I heard, Leah, that I actually read an article regarding the mindset of attacker that you talked about. And one of the scenario was try to understand the business logic or the ROI of a ransomware. So for example, from an investor point of view, who's investing $200, he can actually reach out $1 million after 1 year. Yeah. If he's investing like with people that will write him ransomware, through people that will send the ransomware via emails, trying to attack organizations or individuals. But eventually, they actually published that after 1 year, he will reach $1 million. So from investing 200 into earning 1 million, you know, that's a business case, and this is an ROI, and we need to think like that.
It's a very good business, you know, to be attacker. The ROI is very high, and of course, but you need to be a criminal for this. So it's another thing. Money is not the only thing in life. But yes, but in the sophisticated attackers, not a simple ransomware. And I personally consult to very big financial institutions or institutions from other sectors. So they are prepared for very sophisticated attack. attack that the attackers get inside the network and learn the business processes and know which user does what, and if there is a need to 2 users or 3 users, and which user can wire, I don't know, like $1 million, and which user can wire $100 million, and so on and so on. And they really use the business experts in the business application. Like if we talk about dollars, so the Swift application, the Swift system. And also it's like a common business processes in all the world, how you wire money. It doesn't matter if it's a small bank in Israel or HSBC in London. It's the same. It's more or less the same general process, but there is a distinction between the banks. But the cyber attacker, if it doesn't familiar with the bank process, so you won't know how to do it. You don't know which are how many units there are that they need to check, and where the transaction stops and being checked. So all this information is very important to the cyber attack, to the attack chain, to performing the attack. And when we start to check, when I was employed in the bank, started to check, we realized there are many vulnerabilities and many gaps, and that it's not enough only to protect the perimeter from getting, because we realized that someone will succeed getting into our network. This is our like basic understanding, and from here we need to see what need to be done in order to detect it and prevent stealing a lot of money, maybe most of the money, for example.
Mm-hmm. Did you notice in your work with the biggest institution, do you actually always feels that the human factor or humans are the weakest link, or there are also some processes or business processes that are also weak and can be protected, as you mentioned, like another chain or another cycle of security? That will protect eventually from getting a breach done?
I think the process is the most important, because even though there will be like not so sophisticated employees that checks or operate the process, if you have a very strong and good process with outside controls, I think it will be eventually good. But otherwise, a very smart people with a bad process. So the whole picture is that you are you're in a vulnerable situation.
Yeah. So you are saying it's human factor and human, but also the process might be a weakest link in the chain. So not just the human. Did you see?
I want to give you an example.
Please give an example. Yes, that will be great.
I'm talking now referring to a process that wire securities out of financial institution. Okay, securities, and it's like it's earth money. It's like money. Okay, it's the same. And I found now when I did the BPT, I found a process that the employee just write an email to the counterparty outside of Israel. Write an email, please transfer, I don't know, 1 million in the name of the security to my counterparty, and they're just via email. So you all know how easy it's to write an email and to be like identified as an employee. So the process here are very problematic.
Mm-hmm. Okay, so of course there are things that should be done in order to protect the process,
Yeah,
and of course
of course.
that should be taken into consideration when you are doing a very sensitive business process, such as approving a loan or performing a transaction. Of course. Guys, if you have any questions, please write them down in the chat to Leah. If you have any questions, please write them
Only
down.
guys out there, Leah? You said guys. Only guys out there?
No.
No ladies?
Also females. I can check via the names, but there is more. There is Ella and other people, and of course
ladies and
ladies.
gentlemen.
So ladies and gentlemen, so please write your questions to Leah in the meeting chat. If not, I would like to say, Leah, thank you very much for your lecture. It was very understandable from business perspective, because we are always, as a security professional, seeing in our own eyes from the technical perspective, but in the end, it's business, and if there is no business, there is no security. As Shiran said, not just enablers, but actually going with the business and protecting the business. So thank you very much for your lecture. It was great, guys. If you have any question, we will leave some time in the end of the meetup. But thank you very much, Leah. Thank you.
Thank you for having me. Thank you.
Of course. So I do want to invite Omer Zucker, who is a Pentera product manager. He has more than 15 years in InfoSec experience. Actually, he was the former of Security Intelligence Center, led into Mercedes-Benz. And also he served as in the IDF as an officer in one of the intelligence unit, but he will not talk about it. He will focus about ransomware ready and how to change from awareness of ransomware to become a ransomware ready. So, Omer.
Thank you, Leo, for the for the opening. I'm very happy to be here today. So I think first, in terms of agenda, we are going to discuss about automated security validation and explain a bit what does it mean. Next step will be to discuss the ransomware problem and how we engaged it in Pentera, how we solve it from our end. And at the end, I hope it will be to see an interesting demo from our product. So let's start.
You have the control, Omer.
Oh, okay, perfect.
But be gentle.
I'm trying to click. It's not working.
You are in control. Just click on the mouse or down.
Oh,
yes.
Great. Okay, so let's talk about automated security validation and what does it mean when we say so. So I guess many of you in this call have been in the situation that you have to run some tool in order to expose, identify, detect your vulnerabilities in your environment or even your assets by some vulnerability scanner or something similar. And you probably got flooded with a huge list of maybe dozens, hundreds, or thousands of vulnerabilities, and you didn't know where to start from. And it's a bit, it is a bit sucks because you get a long list and you want to be really active and have some actions. And actually, at this point, when a typical vulnerability scanner stops its work, Pentera starts. So Pentera takes these kind of long list of vulnerabilities, flows, misconfigurations for in the real world, I would say, and it starts to exploit it by a real exploitation that is actually being developed by the team of Spivey, who's also speaking here today. And Spivi's team is actually developing on daily and weekly basis new capabilities, exploits, and payloads that actually engaging these kind of vulnerabilities. And we see that from the flood and long list that we see at the beginning, we got only maybe several or even dozens of vulnerabilities that are actually exploited. And also, you know, if you read some stats from the past 2 years, you can see that only 2 to 5 or maybe 2 to 10% of the vulnerabilities that are getting published on daily basis are actually can be exploited. And the output of this process, or maybe one of the goals of this process, is to perform a real validation of security controls. So imagine that you have an AV, an EDR, firewall, whatever, you name it. And Pentera actually tries to exploit and really validate your security controls. But it's also not enough, because you got the list, but you know you want to know with what to work and where to start. So Pentera actually takes these lists, these kind of lists automatically, and start to prioritize based on different kind of parameters, like I guess you heard about CVSS and MITRE, and we take the likelihood and probabilities and the distribution of the vulnerabilities in the network. And then we get a really refined and updated list that is really focused and tell you what to do. You need to start with 1 to 3 and not with thousands. And the next step will be a remediation with concrete actions and mitigation efforts that you need to engage in order to resolve these vulnerabilities. So to summarize, these are the 4 milestones, I would say, that are assemble our automated security validation platform: exposure, validation, prioritization, and remediation. And you can guess that we are doing so, as I mentioned, by real exploitation. But when I'm saying real exploitation, behind the scenes, we are using many kinds of techniques and procedures that are actually aligned with the MITRE framework, starting from network recon, sniffing, cracking, relay, lateral movement, PE, and many more techniques. And this entire life cycle is actually reflects in a really good way what we are doing in our product and how we can validate for real security controls. But this was just the background about automated security validation. And now we are going to move on to the ransomware ready. And let's talk about the problem. I guess all of you heard read the news on daily basis, and you see that every Monday and Thursday we have a new victim somewhere. So here I just put different types of examples of major events in the wild, including the Cassia attack, in which the attackers demanded $70 million payment. This was our evil group, and also the JBS at the bottom left that paid $10 million to our evil group also. And we see more and more events, mainly I would say even in the US in the past 3 months. And at the bottom right, you can see actually a very interesting statements by the FIRE ICO Kevin Mandia that says that the rise in ransomware requires strong government response. And actually, the White House took one step forward and published some memo with 5 best practices on how to mitigate, and also the FBI was involved. And we see that a lot of involvement and engagement from the US government with the victims. So let's talk about a bit some stats, and actually correlates with what Leah also talked about. So ransomware is not going anywhere. We see that this is like immense risk and actually evolving and growing all the time. And the stats saying that $20 billion, a huge amount of money. This is the amount that projected amount for ransomware damages. And I'm not talking about the payments that the victims pay. I'm talking about the overall picture, including the reputation and the resource allocation that the victims need to engage. So all this wonderful package is a huge bucket of money. We witnessed that more than doubled. This is the percentage of number of organizations impacted by ransomware. And this is compared to 2020. And we see the stats are always growing from month to month. And this is really, really frightening. And the last one is more than 50% of all cyber insurance claims accounted for ransomware. This is also interesting and correlates to risk management and how we need to treat victims and so on. On the right, you can see some examples from the different different kind of ransomware groups, really famous ones. We will talk about 2 of them today: Maze, Ryuk, Evil, Zeppelin, and Dharma. And this is the average cost for each one of them. So let's talk about how Pentera, how we engage this problem. So as I mentioned, as a part of our approach, we constantly adding to our product offensive techniques and procedures by our amazing research team led by Spivi here. And at the beginning, we thought that, okay, ransomware is another cool, new cyber innovative technique that we need to add to our product. But eventually we understood that this is not enough, because ransomware is not a single technique, is actually a huge world that comprises of different threat actors and innovative capabilities that we need to approach differently. Okay, so actually, at the end, we thought that it might be great to take the most dangerous and distributed threat actors. I'm talking about the Maze and Evil, and actually mimic the exact behavior as they do, but for real, and actually to do it automatically. So we took these threat actors, we analyzed them, and we developed an automatic framework for ransomware that mimics the same behavior, including the different phases of the attack, starting from launching the attack, process injection, exploitation, encryption, data exfiltration, and much more. I will deep dive in the demo. And the goal the goal of this framework is not actually to just to have cool new techniques and deploying them in our product, is actually, as I mentioned, to validate our customer security controls. So when you deploying this product in some environment and you will click it, and it's really straightforward. I won't touch configurations today, but once deploying it, you actually can test and validate whether your security controls across different layers are configured properly. So you can see that your EDR, we have many customers that think that they bought the most amazing technologies out there. We have EDR XYZ, we have firewall, we have some WAF, we have amazing solutions. But at the end of the day, these kind of amazing solutions are not configured by those who operates them. And this is the problem. The problem is the human being. eventually. And by Pentera, by this framework specifically for ransomware, you can validate that they are. And of course, the output will be by the system or some report that indicates about AV and EDR bypass, the vulnerabilities that we found within that process, and of course, as I mentioned earlier, guided remediation. Let's take one step forward and see some under the hood view, specifically of the Maze campaign. Just to go over the overall flow and how we implemented it. So you have the big picture. So we're starting from the assuming breach approach. We're already in the network. And we are starting with some credentials and initial access. By these credentials, we are starting to perform host enumeration over the network. We have an extensive RCE framework, including different executors, downloaders, many kinds of techniques, starting from Bits admin, curl, CMD, and you name it. Then we're going to the next phase of like on the host itself, performing file enumeration and encryption with the real algorithms of Maze or our evil whatsoever. Data exfiltration, starting communicate with some CNC. And at the end, since our product is safe by design and we cannot allow any discrepancies in our customers, we perform a cleanup that includes a complete cleanup of all our residues. And all these goodness, I would say, is aligned actually with the MITRE framework, as I mentioned earlier. Okay. If there are any questions before the demo, maybe this is a good time. I don't see any.
No, there is no questions. Maybe further on. Let's continue.
Okay. So Leo, actually, I need to.
Yes, I will stop
control,
sharing.
Yeah, perfect. And need your approval to share.
Yes, you can share.
Perfect. Okay. Can you see the screen?
Yes.
Amazing. Okay. Just a sec. Okay, so you can see Pentera product. So I'm not going to brief the entire product because it will take some time, but I do want to show you today some specific test, a ransomware ready test that we performed in our lab. So all the environment you will see here is, of course, virtual, artificial in our lab. So no customer or any related data here. So you can see here that actually after doing some quick configurations with the click of a button, it's really straightforward, really easy. You just click run the attack, and Pentera starts its journey and actually attacking for real the network. So no simulation, no like exploits or some similarities. It's the real thing, real exploits, real payloads, as you can read and download from GitHub, for instance. And of course, some of them are proprietary for the product. So you can see here a test in which we discovered 6 devices in the network. 5 devices are workstations, 1 server. You can see that Pentera achieved 34 achievements in total that are classified to 4 different severities: critical, high, medium, and low. And here you can see the achievements. So let's deep dive on the attack map. And this is really cool because here you can see the actual flow Pentera managed to initiate. So as I mentioned on the slides, we've started with some credentials provided by the user as an entry point. From the 7.1 to 3.4, I won't talk about each one of them, but this is actually our extensive RCE framework, which is really dynamic. You can see that we open a remote channel, we execute code remotely on the host, and the payload established connections with Pentera, and we upload the malware to host. And you can see that by performing all these actions, no AV or EDR was detecting us in this case. And here starts actually the interesting part that is related to the ransomware. So once we uploaded the malware to host, specifically here by some LOLBus payload, Pentera actually generated an encryption key. You can see here that the ransomware family that we run here was REvil. The encryption algorithm was Salsa 20. This is the original and real algorithm we implemented A to Z. And Pentera encrypted a keybase 64 encryption key on the host. By doing so, we started to enumerate the files on the host. As I mentioned, since we are safe by design, we cannot manipulate the original files. Since we cannot corrupt or manipulate an original file on the customer's environment, so Pentera actually enumerate these files and create copies, as you can see here, like doc1.txt with a proprietary extension. Here, in this case, abbreviation of Pentera backup. So the files themselves are real. This is the original files on this specific host, 3.9.9. But the files you see here, the original path was like administrator documents, and Pentera created a backup file so we can start our manipulation. The next step will be performing the encryption. So we approached these previous files, and we started to encrypt them. The encryption mode here was fast. It means that we actually, in this case, we actually encrypt only part of the file, not the entire binary. This is like a really common configuration field that is actually being performed by both REvil and Maze. As I mentioned, this is the Salsa 20 is the algorithm, and you can see here that the file extension was actually changed. So we have managed to perform the encryption, and now we see that doc1 is encrypted by this extension. The next step will be, and this is really cool, since as I mentioned, we mimic the exact behavior. So the next 3 steps are actually authentic IOCs that are used by REvil specifically. And if you will Google it, for example, and you will write REvil IOCs, you will see that REvil are actually creating configuration in Windows registry by writing these same keys. So we took the original original keys, and we actually writing them in the registry. And you can see here the values and the path and the type and everything. So this is the first IOC. And as I mentioned, we do validation. So we expect that some EDR, for instance, that is deployed on that host will trigger this, will detect this, or even block such an IOC. And this is the shield here resembles a vulnerability, and we see that that the AV didn't block our malicious payload in this case. The 2 next ones are also unique and proprietary IOCs that are related to REvil. This is the mutex creation. So REvil in practice actually creating a mutex object, and this is the you can see the object name here. And the next one will be emulation of shadow copies deletion. And this is a proprietary command being performed by our evil. You can see here a tiny flag, the question mark. So we don't want to actually delete the shadow copies in our client's hosts. So we're performing the command with this flag only to check that, as I mentioned, the EDR or the AV catching or blocking the run of this command specifically. Here is the VSS admin data.exe. Last but not least, since we have completed all the required actions that Pentera have aimed to achieve, so we are triggering here an achievement that says that Pentera completed the ransomware attack kill chain on that host, specifically for 3.9.9. And if we had many hosts in the network, so you will see a multiple achievements, of course. So this is our end-to-end attack flow. And also on the arrows between every achievement, we have some analytics, including the adversary level. So how complicated or how much effort we put in order to go from object A to object B, from achievement A to achievement B. This is the adversary level, the related MITRE techniques for the actions we performed, and of course the timing and parameters. Another cool thing here is the MITRE matrix. So for each test, we are displaying the MITRE techniques and procedures that were performed by Pentera. And of course, we have a report that aggregates all the security findings for executives and some stats. Maybe to show just a quick example. So you will see an introduction about the flow, some context about our evil, some stats and aggregation about resilience score of the client, the action success rate regarding the actions and the MITRE and so on. I won't talk about the entire report today. That's all. Thank you.
Okay, Omer. Guys, if you have any questions to Omer, please write them down in the chat. We have two questions. The first from Zisi. I hope I'm pronouncing it correctly. Were those real IPS from Maze in the data exfiltration stage that you presented?
Yeah, so we have three modes in the product specifically for this feature. The default mode will be no exfiltration, since it's really aggressive procedure and we would like it to be manageable by the customers. The second option is a configuration option in which the user can configure what kind of C2 he would like to communicate with. So for example, if you are testing your segment A in your network and you would like to check that your some server in segment A can communicate with some C2 in segment B, so you can configure it and put your some IP address or domain or whatever. It can be segment B on premise, it can be in the cloud, it can be some VPS in Thailand, you name it, and you put your configuration and then Pentera will try to communicate. This is mode number 2. Mode number 3 is the most aggressive one. We actually take the real IOCs, can be Google, just write our evil and IOCs. We take these IOCs, put them in the product, and Pentera actually will try to communicate with the real IOCs. Of course, there is some notifications, approval by the users. We are not doing it by default because it needs a really unique approval by the user to do so. But the most aggressive option is totally to communicate with the real ones. And of course, we have the assumption that these are shut down because they were published and so on. But the purpose is not to communicate with them. The purpose is to see whether we can actually cross your network to the outside and get back, and to do this pinging and to see if it worked. This will be the goal.
Okay. So there is another question. I don't know if you can answer that, but it's a question. Did you make some kind of statistics? Which security providers were better in offense? Which AV, firewall, EDR, things like that? So it's a bit a tricky question, I think.
Yeah, I can answer. We are not indicating who is the best or worst, but within the report and in the product, we have statistics regarding what kind of security solutions you have and what were the success rate. So for instance, you have an EDRX. I don't want to mention names. You have EDRX. So Pentera will display how many hosts with this EDRX have managed to block our ransomware and how many didn't. So you got a classification of your entire EDR solutions, for example, or your AV that Pentera was detected during the test. And what is the statistics? We don't tell you who is better. You can see by the results, but I can guarantee that we have customers that totally can block us because they have really good segmentation, configuration, and so on. And we have customers that have the most, let's say, prestige security vendors and solutions, but they are not configured properly, and we bypass them, for sure.
That's interesting because when a provider provide you some product, he said that it's always bulletproof or 99% bulletproof, and when you're implementing it in your network and you have your own use case or your own segregation, as you said, or a type of backend service, front end, that doesn't matter. Your architect, eventually. It's another chain of a protection. It's not the last one, not the first one, not the last one, but rather than a defense in layer, how we are saying that. And as I understand, your product actually check all the defense layers in the attack scenario, so you can see like the points and where were the failures in your each and every chain and the attack scenario itself. So you can be, of course, better and improve. So it's very individuals. And correct me if I'm wrong, Omer. And of course.
And I can additionally share that we see really on weekly basis customers that has the wow effect. Oh, we invested so much money on this and that technologies, but suddenly you see the test and you see, oh, they didn't work properly. What did we do wrong, or why we bought them at the beginning? And it's really interesting to see how the customers react to real check, let's say.
Okay, guys, if you have any questions, please write them down to Omer. If you have any questions to other panelists, please write in the chat. We'll give several minutes, guys. If you have any questions, please write them down to any panelist that we have. Let me go through the questions to see if we answered all, and if there are any open that we didn't answer yet. So I think there is an open question, Shiran, for you. Okay, so what security frameworks would you suggest for a crypto fintech company to follow as a must, as a mandatory?
Yeah, so we started to say that the ISO standards, that's a must, and NISA standards, the European ones, and NIST, of course, and Cloud Security Alliance, and anything related to again, the application level, infrastructure, the known frameworks. Take that, create your own tailored suit, customized suit, and follow that. Yeah, those are the best practices. In addition, there are specific crypto-specific ones for smart contracts, for blockchains, for the types of attacks that you'll see there. We talked about some of the attacks, flash loans and various rug pulls, yeah, that decrease the prices of the assets and such. So it's a mix of the known ones and then specific smart contract blockchain related ones. And again, the best thing here is, again, everything or a lot is based on cryptography, as we said. You need to protect the keys, you need to use the correct algorithms and such. So it's a mix, yeah.
Mm-hmm. Is there a specific framework for, blockchain or hardening?
For smart contracts, yeah, smart contract attacks, yeah, there's a specific framework for that. Common attack vectors for smart contracts, again, has a very specific name. And these are things that we look at. There are various scanners, like you have AppScan and other HP and IBM and such for the current code framework with OWASP results. Then there are results and MITRE results and others. Then you have specific results that the scanners present for smart contracts. Yeah, so very similar to the legacy attack vectors and applications and code, but for smart contract attacks, smart contract languages. Yeah.
Mm-hmm. Okay. Another question that was asked for you, Shiran. How do you manage the priorities with all the things that happening now and also plan for future? Like, what will be your highlight recommendation or top 5 recommendations?
So for the crypto sector, there isn't one dull moment. Yeah, first of all, it's really amazing people, passionate people. That's a must. And that includes the security team and DevOps and developers and more. So first of all, it's the people thing. Then really prioritizing and such, same like in the regular banking, financial ecosystem, yeah, use relevant information systems that manage the tickets and prioritize the risk and specify the specific risk in a risk register. So understand the types of attack vectors, do continuous risk assessment. So that's another tool like we have in the legacy non-crypto world, you could say, that we use. The trends going forward, again, is having multidisciplinary people dealing with these topics, meaning people that understand fraud, people that understand corporate entities, how to do due diligence on platforms, people that understand the money aspect. We said it's not only finding XSS or CSRF or whatever, various command injections in code. Yeah, it's understanding how money can be stolen through this command injection or buffer overflow or excessive or redundant parameter and such. Finding the business logic exploits that are just unique. Yeah, they're unique because it's a different language. Borrowing and lending on the blockchain, yeah, various trades that happen on the blockchain. It's different than accessing, let's say, through parameter manipulation and a different client's contracts or data. Yeah, here it's more, again, we're dealing with theft, yeah, of money, of assets. You need to understand the business, you need to understand the financials. Yeah.
Mm-hmm. Okay, thank you very much for clarifying that. There was a question for Spivy in the beginning. Spivy, one of your, I think it was related to the login example that you showed. Like there was a question from Arangel. So what if you can't even invoke the login form directly? You cannot get to login form of OIDC or providers unless you have started a proper authorization request from the application itself. So how would you attack that?
So specifically, this kind of architecture is meant to prevent those types of attacks that I've mentioned. So this constellation, when you work in front of authentication server, the login form is irrelevant. And this is a great example of things that our automation doesn't deal with, but we are working on. But hacking wise, I'm happy to say that not every web app implements this type of architecture, especially on-prem applications like internal management web applications like your routers, firewalls, internal apps. So for the on-prem penetration testing, you likely won't see this one. And the external applications, that's right, there is that type of solution that prevents this type of automation to give you a penetration testing value, but there are many more, and the majority doesn't implement this type of work in front of authentication server.
Mm-hmm. Okay.
Maybe in the next session that I will have some new news about how to enhance the automation and work and bypass this one as well.
That will be great. I think that will be awesome for us to see that also. Okay, so guys, if you don't have any further questions, if you have, please write them down in the meeting chat. If not, we will wrap up. Moreover, I do want to say, listen, we are growing. Our Meetup group is growing. We've reached 2,000, something like 2,000 and a half 2,500 people in our LinkedIn group. So guys, you are more than welcome to join us to get the newest updates. Also, all the recorded sessions from today Meetup will be uploaded to our LinkedIn page, and you can get also the updates for the nearest Meetup. Guys, so if you don't have any questions, I cannot see any further questions in the chat. Okay. So I do want to thank all guys. I think it was very technical, very unique Meetup. We talked about the solution, we talked about the attack from business perspective, from the framework of cryptocurrency, and also solution and how to become more aware of ransomware. So guys, thank you very much. Thank you, Spivi. Thank you, Shiran, Omer, Leah. It was a pleasure, and thank you all for joining. So keep safe, guys. Keep safe, and thank you very much, guys. And see you on the next Meetup.
Thank you, Leo. Bye. Thank you.
Bye for now. Bye all. Thank you all very much. Bye bye. Have a good evening. Bye bye.